Hi again. So last lesson, we went over how to import sketch plans from Rhino and distribute them to given heights according to our defined levels. Now what we want to do is use the information from our sketches to cut out more refined floor plates and then be able to get useful information out of those. So when we look at the volume defined by our setbacks and our multiplied floor plates, you can see that we need to find the intersection between the floor plate and the allowable volume, because this is much more than we can build. So for each level in our first exercise, we'd cut out a curve. So that's this. And we also have all of the floor plates, which would be our target floor plate. We need to find the intersection between these. So I'll just hide almost everything here, so we can just do this more clearly. When you take these and intersect them, you obtain the region that meets both requirements. We turn this into a surface, and we can see what we're creating. In the areas where we sketched all the way up to the setback, that conforms to the volume. The areas where our sketch floor plate went inside a bit, that then comes inside from the setbacks. So now we can decide which of these floor plates we want to keep. We probably want to reduce the number of residential floors because most of them aren't very useful if they're too small. So let's say 10 is okay. Now what we want to do is insert the void, which we had drawn, into this. So our voids were only on the residential floors in this position. In order to add these to our surface, we'll just merge the results of the intersection with the voids, and remember to always simplify when you merge, because that eliminates any possible problems with the branches. So when you do that, it creates a surface with the voids cut into it. Now that's a very simple representation in terms of area for our sketch. But we want to go a bit further as well, because when we sketched per plan, then we get voids that are basically extrusions that are the same all the way up. What if we want to create a cut into the surface that is changing vertically? in order to do that, we want to somehow modify this original volume. We'll do that with more sketch layers, which we'll call guides. And within guides, we'll create a new sublayer called voids. Now, when I sketch something here, it can be 3D. So let's just say at this corner, we want to pull it in to create better views on an urban level. So what we'll do is just draw a pyramid that corresponds to what we want. And you can sketch this more carefully if you want. And say that's how high we want it to go. We'll need to add another geometry pipeline component. Call it voids, corresponding to the layer, and import the brep type. So that should be in there. Now we'll play with intersections and create a subtraction, a difference operation. So now this void is in Grasshopper, and it's being subtracted from our volume. And if I connect this then to our script, we get this shape influencing the volume. Now it's also possible and useful sometimes to have another type of 3D guide, which we can call a form. So here, say I want to draw a cylinder. And I don't want anything to lie outside of the cylinder. We then input that as a form. And in this case, we want to intersect it with our volume. So everything that lies in the original volume and inside the cylinder gets kept, and everything else gets excluded. So we'll just hide this geometry, and you can see how it's affecting our volume. And this is all totally parametric. So if I want to move this cylinder, then my form gets changed, and everything else that follows gets changed. So this is a great way to sketch very quickly with 3D shapes as well as shapes in plan, and get useful information from it. However, in this case, the cylinder ends up being a little too silly, so we'll just delete that and keep our original shape here. And that's how you can sketch in 2D and in 3D and come away with a model which we can then analyze numerically. And that's what we're going to do in the next lesson. We're going to extract all of the useful information that we can from this model and come away with some correct assessment of what this development is and whether it's viable or not.